Alexa, show me the front door.
Okay.
Look at that. The Echo Show pulls up your doorbell camera, you see the delivery guy, and everything is great. For a few minutes, anyway. Then the screen times out and goes back to showing you the weather and an ad for things it shouldn't know that you want. Depending on the camera brand, you get anywhere from 2 to maybe 10 minutes of live view before Amazon cuts you off. There is no setting to change it. People have been asking in the Ring forums for years, and the answer is always some form of, that's just how it works. And of course, that's how it works. Your video is going from your camera up to their cloud and then back down to a smart display in your own house. Every minute you watch costs them money. And if you watched my earlier video on home cloud cameras, including doorbells, you already know why you should switch. Today, I give you another reason. Maybe you have a reason for an always-on view, a front door, a driveway, a pool so you can know at a glance that the kids and pets are okay, a sleeping baby, a dog that wants to be on the chair that he's most certainly not supposed to be on. With non-cloud connected cameras with local storage or with an NVR, you are in charge. Today, we're building a dedicated camera monitor, a little touchscreen that sits on the counter or mounts to the wall and shows your cameras all day, every day. Tap it to change cameras, and it even does a grid view. Press and hold, and the screen goes dark until you touch it again. No cloud, no subscription, no timeout, and the whole thing uses a few watts. Welcome back to Dad Builds Stuff. Here is the finished product. It's a Raspberry Pi 4B connected to a generic 7-inch touchscreen in a little case that I printed on my Prusa. It connects with RTSP, which is an open streaming protocol that practically every decent camera system already supports. Reolink, Amcrest, Hikvision, Ubiquiti. Most NVRs, like Frigate, Blue Iris, and even the Reolink RLN8-410 that I covered previously, restream every camera that you have. Neat. One tap, next camera. Keep tapping and you land on the grid, with up to 4 cameras at once. Press and hold for a second and the backlight shuts off completely. The Pi is still on, still connected, but the screen is black and dark. Perfect for a bedroom at night. Touch it anywhere, and it wakes right back up to the camera you were watching. There's also a patrol mode, where it automatically rotates through your cameras on a timer that you pick. Set it and forget it. Today you're going to assemble the Pi and the touchscreen, flash Raspberry Pi OS Lite, install a video player and one small Python script, find your camera's RTSP addresses, set it to start on boot, and then test everything as we go. If you've been following this channel a while, I made accessing a Linux device via SSH fun and easy. Today we will do the same with an easy project that introduces the aspect of simple assembly of hardware. If you can follow a recipe, you can do this. And, as always, if you get stuck, drop a comment and I'll help. What are dads for? There's a worksheet linked in the description with every command ready to copy and paste, plus blanks to write down the stuff you'll need later. There's also a full parts list, and there are links in the video's description. Print the worksheet. Crossing things off a list feels great. Full details are in the parts list, but the short version is this. You need a Raspberry Pi 4. The 1GB model is plenty, and it costs $35 at Micro Center. Fun fact, you probably won't want a Raspberry Pi 5. Why, you ask? Well, these cameras and NVRs can encode the RTSP streams in different formats. H.265 is the newest format that you're likely to see in the wild, but H.264 is still very common. This is important because the Pi 5 actually dropped hardware H.264 video decoding. The Pi 4 still decodes H.265 and H.264 in dedicated silicon. The older board is genuinely the better tool for this job. How often do you hear that? Next, you'll need a 7-inch DSi touchscreen. I'm using a Hikvision panel, or however you say that, at about $35 a piece on Amazon. It's the same 800 by 480 resolution as the official Raspberry Pi touchscreen because it's essentially a clone of it. And to the operating system, it looks like one. Plug and play, no drivers, and it even powers itself through spring-loaded pins, so there are no extra wires at all. If you have the official display or one of the other clones like WaveShare, everything in this video will work the same, and I'll flag the one small assembly difference when we get there. Then you'll need a stand or case. The Hikvision mounts the Pi right on the back with the included standoffs, and there are cheap stands and free 3D printable ones for it as well. If you're using the official display instead, the Smart Pi Touch 2 is the classic choice. Finally, you'll need an official USB-C power supply and a microSD card. 16 gigs is more than enough. All in, if you're buying everything new, you're at around $80. If you already have a Pi and screen handy, this is a weekend project that costs you nothing. One note on cameras. Your cameras need to support RTSP, or at the very least, your NVR needs to support RTSP. Most wired security cameras do. Most cloud-only cameras like Ring and Nest do not, because of course they don't. But you already saw my home cloud camera video, so you're looking to get rid of those cameras as soon as possible, right? If that's what you have, check my home cameras video, linked below, for gear that respects you. Step 1 is to flash Raspberry Pi OS Lite. On your regular computer, download the Raspberry Pi Imager from raspberrypi.com. The link is on the worksheet. You're using Raspberry Pi OS Lite, the 64-bit version. That's the one without a desktop. We don't need a desktop, a browser, or even a mouse. Our video player will draw straight to the screen all by itself, which keeps this thing fast, cool, and stable enough to run basically forever. In the Imager, you'll select Raspberry Pi 4 as the device, Raspberry Pi OS Lite 64-bit is the OS. The storage will go to your microSD card. The host name you'll pick and write on the worksheet. As far as the username is concerned, I'm using NetServe. Pick a good password. Write down both. Wi-Fi. Normally I tell you to use Ethernet, and that's still the most reliable option. But this build is a display that you'll want to put wherever you want to see it, so Wi-Fi is forgivable today. Enter your network name and password. You have my blessing. Just this once. And then you'll enable SSH with password authentication. You'll write the card, eject it, and put it in the Pi. Step 2 is to assemble the hardware. This is very easy because you're only attaching one ribbon cable. It carries everything, video and touch. With this screen, power comes through the pogo pins. Then you'll take the flat ribbon cable that came with the screen and connect the display board to the port labeled Display on the Pi. On each connector, slide the little retaining clip up. Slide the ribbon in with the silver contacts facing the right way and press the clip closed. It should sit straight and should not fall out if you tug it gently. Then screw the Pi into the back of the display. With this display, you add the brass standoffs to get it to the right height for the pogo pins. Then put in whatever stand or mount you're using. I've got the link to the 3D printed wall mount case on my worksheet. That's the whole assembly. No jumper wires, no soldering, nothing. One note for folks using the official Raspberry Pi touchscreen instead. Yours doesn't power over the pogo pins, so you'll add the 2 included jumper wires from the display board to the Pi's GPIO pins. 5 volts to pin 2 and ground to pin 6. That's really the only difference, and everything else in this video is identical. Now power it on. You'll see text scroll by on the touchscreen and land at the login prompt. That's exactly right. Leave it there. Find the Pi's IP address from your router's client list or by pinging the host name from your computer that you set in step 1. Write the IP on the worksheet. Step 3 is to connect in and install the software. From your computer, open a terminal and SSH in using the username and IP from the worksheet. If you need a refresher on SSH, I recommend watching the linked video for Pi-hole. Then update the system and install our 2 ingredients, MPV, the video player, and the Python input library that reads the touchscreen. That's the entire software stack. One player, one library, super simple. Step 4 is to find your camera's RTSP addresses. Every RTSP camera has a URL, like a private web address for its video. It looks something like this. The worksheet has the URL patterns for common brands, Reolink, Amcrest, and Dahua, Hikvision, and Frigate restreams. You just fill in your camera's IP address and its credentials. 2 important tips. Tip 1. It helps to use the substream and not the mainstream. Almost every camera sends out 2 feeds, a full resolution one for recording and a smaller one for previews. Our screen is 800 by 480. The substream looks identical on it and uses a fraction of the CPU and network. On Reolink, it's the URL ending in sub. On Amcrest, it's the subtype equals 1. It's on the worksheet. You can view a full 6 megapixel stream, but I don't know why you would do it. For this demonstration today, I'm using a Blue Iris NVR that has the output set to 800 by 480. Tip 2. If your camera password has special characters in it, they may need to be URL encoded in the address. An @ becomes %40, for example. Or save yourself the headache and create a dedicated view-only camera account with a boring alphanumeric password. That's the better practice anyway, and most cameras support it. Now let's prove a feed works before we automate anything. From SSH, do the following. Then look at the touchscreen. That's your camera, live, on your little monitor. Press Q in the SSH window to quit. If the video came up as expected, write that URL on the worksheet and repeat for each camera. If you don't, test the same URL in VLC on your computer first. If it fails there too, the URL is wrong or RTSP is disabled in the camera settings. The worksheet has a troubleshooting box. Step 5 is to install the monitor script. Now the part that turns a video player into an appliance. I wrote a small Python script that does 4 things. It plays your cameras, switches views when you tap, it builds a 2x2 grid, and handles the sleep and wake. It's about 200 lines and it's commented, and you're free to read every one of them. That's the difference between this and an Echo Show. You can audit your own appliance. Download the 3 files from the link in the description into a folder called RTSP Monitor. For your convenience, I've put them out on my website and they're easily downloadable with wget on the worksheet. Then open the camera list with Nano. 1 line per camera, a name, a pipe, and the RTSP URL you tested in step 4. At the bottom, there are 2 settings. Grid turns the 4-way grid view on or off, and cycle seconds is patrol mode. Leave it at 0 to only change cameras when you tap, or set it to say 15 and the monitor rotates through your views every 15 seconds on its own. To exit Nano, it's Control X, then Y to save. Step 6 is permissions and housekeeping. 4 quick one-time chores, all copy and paste from the worksheet. First, we're going to let the user talk to the video hardware, the touchscreen, and the console. Second, we turn off the text login prompt on the monitor's own screen. We manage this thing over SSH so nobody will ever log into the touchscreen itself, and with the prompt gone, the only thing that can ever show behind the video, even for a split second when switching views, is black. Third is the backlight. The screen's backlight is controlled by a file that only root can write to. This rule fixes that permanently. And fourth, by default, Linux blanks the console after a few minutes, and we're building a screen whose whole job is to never blank. We also hide the blinking text cursor. 1 line added to the end of the same single line in the boot configuration. Again with Nano. Control X, Y, and yes, it all goes on 1 line. That file is famously picky about that. Those last 3 things quiet the boot and kernel messages that Linux likes to print on the console. Step 7. We make it into an appliance. We want this to survive reboots and power blips without anyone having to touch a keyboard. That's a systemd service, and you have already downloaded it. If your username isn't netserve, edit the file and change it. The Pi reboots, the console flashes by, and about 15 seconds later, your camera appears. No login, no desktop, no clicking. It's an appliance now. If the screen stays black, the worksheet's troubleshooting box has the command to read the services log, and 9 times out of 10, it's a typo in the camera URL. As far as using it, it's pretty simple. Tap takes you to the next view. It goes camera, 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 then grid, then back around. Press and hold for 1 second and the screen goes completely dark. The backlight is off, so there's no glow at all. Pi stays on and connected. Tap the dark screen and it's instantly awake right back to the camera you were last on. And if you set cycle seconds, it patrols on its own and a tap still skips ahead. The backlight is also dimmable, and I've put a 1-line brightness command in the worksheet. Pair it with cron and you can have the system automatically dim the light to nighttime levels at 10 p.m. and come back at 7 a.m. if you want. If you'd like a video on scheduling tricks like that, tell me in the comments. And because I'm not going to miss a chance to tell you about Tailscale, I'm going to mention that this device is at my house, but the NVR that this device is reading streams from is at Mom the Creative's business, several miles away. How? Tailscale. And you can do it too. Hopefully that convinced a few more of you to try this project. Also, the program is monitor.py. It's tiny, it's written in Python, which is basically the modern equivalent of BASIC. It's easy enough to change if your display needs are different. You can reach out to me if you want something special and don't know how to add it yourself. And that's it. Look at that. You did a thing. You took some hardware, assembled it, and loaded it with some basic software to make something new. Just like the Pi-hole project was the gateway to getting some of you to start home labbing, this project may be the gateway to some of you building your own solutions, hardware and all. Today, you made a dedicated always-on camera monitor. It shows any RTSP feed on your network, including your extended tailnet, forever, with no timeout. There's no cloud company in the middle watching or deciding how long you're allowed to look at your own front door. It costs about $80 new, less if your parts drawer is as embarrassing as mine, and it draws about 4 watts. The electricity for a year costs less than one of my Lemonade refreshers. The video stays on your network. Nobody's server ever sees it. Nobody can ever end-of-life it with a firmware update. And when your neighbor asks why your kitchen has a tiny TV showing your driveway, you can tell them that you built it yourself, with a computer the size of a deck of cards. As a dad, I couldn't be any prouder. Natural next steps? Recording these feeds with AI object detection. That's my Frigate video, which is still coming. If you want to see this monitor's cameras when you're away from home, that's my Tailscale video, linked below. If you built it, tell me in the comments what's on your screen right now. If you plan on building it, let me know that too. I read all the comments and I try to help everyone. If this was useful, hit like and subscribe and share it with somebody whose Echo Show keeps timing out on them. If you really want to support my work, please hype the video and consider becoming a member. Not a big deal, so it's really cheap, and depending on the tier, we can hang out on Discord. Thanks and have a great day. I'll be watching the driveway in case you stop by.